Eventually, I made my way into the GPUs, and I was at the Voltron Data, and there we were building out a distributed GPU database. The goal there was to basically target the data center scale, so like terabytes of data. I've like seen the same problem again and again, and I think and like it's like the 2024, and no one has solved it yet. I was kind of surprised by that. I started off building xorq as a way to be declaratively express our pipelines. I want to extend SQL, and I want to extend SQL in a way that I can have an operator that can do my scikit-learn the fit step, and then it can do my scikit-learn predict step as well. And those were the types of things that I was motivated to solve. So I can have a single expression that targets Snowflake for, say, my feature engineering, and then it targets data fusion for your transforms, and like a scikit-learn UDF for it, where we don't have a central backend. You can like chain anything you like in this like declarative stateless manner. That something happened in like December or like January. We have LLMs, and like they're gonna like help us automate some workloads to being, it's going to foundationally change how we work.
You don't need to convince the user. You need to convince his agent, right?
What do you think about that? Do you think data engineering gets automated away? I think the deterministic part is pretty important, because how do you verify things are working correctly?
It's the worst orchestrator that exists out there, like Diptychon.
Are you afraid of Markdown for running your company?
Like, I think it's not Markdown per se, it's just like text.
Hello everybody. Today is like the sixth, I think, episode of the podcast, and it's the first in English because we are welcoming today Hussain as a guest on the podcast, and it's actually the second recording we are doing. We had some technical problems, but I think the first one was really good, and the second one is going to be even better. So welcome on the podcast and the show, Hussain. How are you doing?
Thank you so much. I'm doing very well. I was going to say maybe a third time is a charm. So let's keep it open for another pod in the future as well.
Would you like to introduce you shortly, explain what you're doing, what's your background? Because people maybe don't know you, so I think it would be interesting to have an introduction about you.
Yeah, absolutely. I am a founder. I've been building xorq at xorq Labs, which is a data transformation layer, and we're focusing on agentic workloads. Previously, before xorq, I was doing consulting, and I was like fortunate enough to do like early open source consulting on the Hadoop world. So a lot of Python operationalizing on things like Yarn and like Hadoop, which was like this like the first distributed open source data transformation platform, right? Pretty popular in like 2017. So I was doing consulting on it. And before that, I was in the enterprise, and at the enterprise, I was a data analyst. So a lot of the things that I was doing there were building semantic layers and doing, a statistical modeling with a software package called SAS, which had its own language and its own like epoch even, and so on. That was something that I think that the experience was like really awesome, but that also drove me towards that these like tools are not that good. So how do I build better tools? And 10 years ago, if you were a tool builder, you would naturally gravitate towards Python, because like Python was the sort of the data language, open source, and pandas and NumPy and SciPy and scikit-learn were already there and very mature products back then. And like you could actually build out a scaled out enterprise workload with those tools. And so then I started working in the pandas ecosystem. And when you get into pandas, you actually realize that it's not very scalable. So then I started to figure out how to like scale that. And there's a product called Dask, which is also open source. So got involved in Dask, and Dask was heavily based on pandas. And I like started figuring out, okay, how do we do Python native Spark-like workloads where I don't want the overhead of Spark? So it was like lightweight stack. And I think like even then, like my my like mental sort of gravity was more around we should be able to do stuff with a single machine, and we don't really need to reach for a distributed tool. And a lot of the times Hadoop and Spark and these like distributed tools were a large like complicated overhead even back then. And this is like before DuckDB happened. Like I was trying to figure out how to do the streaming pandas on a single node, and like if I can keep my stack simple enough, then I can easily just scale it to other problems. So like that was kind of my work there. And then eventually, like I think like 2 years ago, I realized that I've been solving the same problems over and over again. And these are, how do you productionize machine learning pipelines, or like complex data processing pipelines in a way where you can kind of like have some mathematical rigor around those, and you could easily verify it. And my verification and like that lens was essentially driven by regulated industries, because like a lot of my consulting experience was in like fintech and these regulated places where they will ask you that you need to have column level lineages for all of your models, and that's the law, right? So to like comply with those laws, like a better system is like, hey, it's something that you can which is deferred, is declarative, you can rewrite it or reason about it, and then there's some like mathematical verification that you can do it. That this should like you should have some comfort that it will work for you.
To your single node workflow that you mentioned before, because you used to work at Voltron Data. Did you work on like the GPU powered data transformation project, or like how was it?
That's right. So eventually I made my way into the GPUs, and I was at Voltron Data, as you mentioned, and there we were building out a distributed GPU database. And the goal there was to basically target the data center scale, so like terabytes of data. So like the idea was to become a appliance in like a data center where you can just buy and accelerate your like Spark like workloads. So that was something where I realized that the world is very heterogeneous, and we need we need the things like DuckDB that can compile across different hardware. And I think that is still the case as well. Nowadays, though, I'm seeing there are some single node GPU databases that are pretty good as well. Have you used them at all?
No, but I was wondering, because that was pre AI boom that we see now, I think. And do you think, like, with just 2 years delay, like if the Voltron GPU data platform would exist today, would it be a good fit with like the whole LLM world? Like, how, or like, is it somehow linked to each other? And like more broadly, how do you see then data and LLM? I mean, these two worlds need to work to live together now. And I don't know. Maybe do you have some good?
I have a take on this. Just when I was in SF last year, I went to like a meetup where like people from ClickHouse, Stardust, I think, and another database came to speak. And the proverb and the way they phrase it is, it takes at least 7 years to build a database, and to build like a good database and have like stuff that is working, all the edge cases and stuff like this. And we see at the moment that ClickHouse is starting to be on the on the sunlight, I would say. And I think for GPU databases, as this is something totally new in terms of like mental model, the way like the stuff is done, etc. I would say that even if it was ready like right now, the adoption time and all the stuff that you need to replace all the classic reflex that we have on CPU databases, distributed databases, whereas it's like Snowflake, BigQuery, whatever, it would have taken like at least 10 years. I think it's like super hard like to change like a complete model, mental model of data people, data engineers that are doing stuff. And even if like the GPUs databases are kind of similar, you will have like error trace that are super weird to understand, and all the tooling that is around, everything that is around. People will invent a new SQL language, obviously, that is a bit different, and so I think like the inertia is super slow on this.
Absolutely. And databases are obviously very hard to build, and like it takes a long time. I think one thing that I saw at Voltron Data is that with the sort of like deep learning and LLM type of workloads, like you don't want to contend with data analytics workloads because obviously, training a AI model is way more important than doing a group by, and I think that was something that might have hurt Voltron Data. The other thing there is, like I think to your point that the databases being so like hard to build, and then having their own peculiarities, like their own like SQL dialects and like so on. I think that's something that like I hope we don't adopt in the GPU world. Like I hope we keep the standards there and like make sure that we can like operate within those bounds. My last point there is like, so the data processing workloads are bandwidth limited essentially. So you need better hardware, and you need a way to like get the bytes and bits fast into your the GPUs. And I think that is the reason why you will see accelerators for data workloads as well.
Cool. But I think at the end it should be transparent, no? If you use CPU, GPU for the user, and that's what takes time probably, like to reach the same interface, and that should be that's what I think you meant, Christophe.
Yeah.
And so after this time at Voltron, then you started xorq, I think, no?
That's it. So after that, I was like, okay, I've like seen the same problem again and again, and I think like it's like 2024 and no one has solved it yet. I was kind of surprised by that.
And no, maybe could you introduce xorq, like your vision, what you're working on, and like I think we can go maybe a level over and like try to think about what you are envisioning, what your positioning is in this AI world, which is changing really fast. I think that your vision as a builder is super interesting, especially because Christophe is as well building a dev tool, and I think there is a lot of like vision, like ideas that we can share between you and you, and I think that's what makes this podcast interesting. So could you introduce what you're building and on your vision behind?
Yeah, so I started off building xorq as like, hey, we want a way to be declaratively express our pipelines. And the pipelines that I was essentially building are a lot of like machine learning type of things. So a lot of like scikit-learn style transforms, pre-processing, things that don't quite fit well with SQL alone. And the main thing that is different is that you are doing multiple passes in order to fit something once and then predict it after. And that like multiple pass is not something that like you can do in like SQL that well. So we wanted to essentially say that I want to like extend SQL, and I want to like, extend SQL in a way that I can have an operator that can do my scikit-learn the fit step, and then it can do my scikit-learn predict step as well. And those were the types of things that I was motivated to solve. In order to solve that, you needed to have some kind of a expression system that is relational, and Ibis being that expression system for us. Ibis is a project by Wes McKinney, and at the Voltron Data, we were heavily invested in it. So like Ibis being this like a cross backend or multi backend expression layer that can compile to say like Snowflake or BigQuery or ClickHouse even. And so like they were solving the problem of like write once and not have to rewrite it for a different type of platform. So Christophe, you mentioned the dialect problem. I think that was something that Ibis started solving.
This is fun. Just in now in the open source version, we are relying on Ibis to abstract the backend. And to me, it's like Ibis is super cool, but there are like so many stuff that is still not solved with Ibis. Like there are some backends that are not correctly supported when you want to get some metadata and stuff like this. And this is something that we are chasing, like having a omni technology that does all the backends, but this is super hard to build actually.
It was maybe, no? I don't know, if you have the right primitive now, and you can like have agent like chasing missing adapters, right? No,
But
and
the
help
issue is
writing
that
the
you don't
platform.
have the primitive of the closed-source warehouses. You lack so much stuff like from closed-source warehouses, so you have always like to catch up or try to understand. And this is what DBT tried to do also with Fusion. It takes like months, years to reverse engineer the closed warehouses to understand how this function behave. What are like the types that this function accepts? For instance, like a sum function might accept like 10 different types with different combination, and you have like to test everything, get errors, adapt, and so on. And this is the issue with the dialects that are like closed source. I don't know if you feel the same, Hussein, but
I do, absolutely. This is the issue, and I've like seen it over and over again. And even in like Ibis land, I think what it's going to solve is like make sure that it is properly compiling the SQL for the backend that ties back to the operator that you might have written in Ibis. But what it's not doing is any just semantic understanding of like, hey, like UDF in MySQL like acts the exact same way as a UDF in Postgres. Those just semantic differences are like something that like Ibis cannot handle. And so, but like also, I'm not quite sure how important it might be to handle those, because like a lot of people who have a database or a compute engine, they're relying on it as their core of their infrastructure. Like I think with like DuckDB things are changing, which is kind of nice. But yeah, I think it is like I think that's a very hard challenge. So a closed the more a closed the system is, the harder that challenge would be. Like say like IBM DB2, if you want to learn about the internals of it, that's gonna be a long time.
And what's your vision then on the long term for xorq vs Ibis? Do you want on like all these adapters problem?
Yeah. So Ibis is single sessions, right? So you're bound to a backend, and you are operating on that backend in like a single session. So you can think of it as like you have some like SQL strings, and you are connected to your database and executing them in an interactive way. So like what we are is, and then Ibis has multiple backends. So it is able to say like I can compile the same string or like same expression for multiple backends, but like what it does not do is a multi-session, multi-backend, which means that I am now cross backends. So I can have a single expression that targets Snowflake for say my feature engineering, and then it targets data fusion for your transforms, and like a scikit-learn UDF for it. That is a single job, or like a single declarative expression in xorq world, but it is multi-session because it is orchestrating multiple connections to say Snowflake and Postgres, and it's also a cross backend because you are making sure that you can get data from Snowflake into Postgres. And that is kind of the thing that like xorq is trying to solve for. We are not solving for the problem of a semantic mismatch between one backend or the other.
So your goal is like to make multi-engine like native, and like behind xorq CLI, then you can easily pipe data from one system to the other one and have this kind of multi-engine orchestration solved, right?
That is exactly right. And I think we are close to that now. So we've been working on it for over 2 years. So we are getting to a place where we have a pretty significant or a good coverage with scikit-learn, and we can you know we can confidently navigate multiple backends. So it's in a good spot.
Cool. And just one question, like funny question. I think like this is something that you can do with DuckDB in a sense, like because with DuckDB you can build plugins that connects to external system, like with kind of foreign data wrappers and stuff like this. And so in the end, with DuckDB you can do this with SQL. So SQL is your piping language in a sense, or you can also use the CLI with DuckDB, and you have SQL that you pipe one of the other with like the CLI. If you were building it today, would you still go like with Ibis, or would you want to build it also on top of the DB? Because
so we are like heavily used the DuckDB. DuckDB is like one of the the default sort of like backends.
yeah,
And like absolutely love it.
but it's
So
a single backend. I mean, you could use it not as a single backend, but as the system
as
that
like
is orchestrating in a sense.
so they have like extensions that can talk to Postgres or
Yeah.
like Iceberg, and then you use a DuckDB as your like engine for it. So that will okay. So like if you like to think about that workload, that'll be like a federation workload, right? Where I want to federate MySQL queries. Like Dremio comes to mind. I
Yeah.
don't know if you have or like others maybe as well. So that would be like you have the end to one, right? So you have like the end backends, and all of them come into one backend. What xorq is more like end to end, where we don't have a central backend. You can like chain anything you like in this like declarative stateless manner. So you can say there's like a Snowflake, there's a Postgres, there's data fusion, there's like DuckDB, and like all of that is like it's like arrow the record batch streams being pointed to those backends. So like in that way, xorq is a stateless orchestration layer, right? We don't have any like state because we don't need to do like checkpointing and like retries, a lot of that. It's just a job. If it fails, you just like restart it. It will like start from its last cache point up automatically. So it's like here's how, like, instead of using Airflow to tie together Snowflake and Postgres, you use you basically use like xorq, because you don't have to do any like task management there.
Makes sense.
And maybe we can introduce then AI now on like what has changed for you like the last few months, like in the way you build xorq, like your vision for it, and like how has it changed or not, and that what's your standpoint now?
I mean, there's so much changed. I think I was just like talking to you earlier that something happened in like December or like January, where things were like pretty much was like, okay, yes, we have LLMs, and like they're gonna like help us automate some workloads, to being, oh, it's gonna foundationally change how we work, especially in software development. But like in general, I think it's like pretty much like Claude Code is like a generic agent to me. So I think that's where like like the changes happen. And now in the last like 3 months, it feels like it's been like 4 years. It's like such a long time, because we have like gone from sort of like this like a story of building or like automation to like compounding. And this like compounding is quite interesting, because now you can have multiple agent or like agent swarms doing work that can compound. And once I realized that, I so like we did like a pivot at xorq. And the pivot was like, instead of focusing on a machine learning operations or like sort of this like ML ops workload, we want to figure out how to be part of the agent harnesses. So like, how can we be part of the Claude Code agentic loop? Because that's where everything is going. You need to be bound to the token somehow. And the data layer is like, I think, one layer above those like the token economics. But so like, how do you connect the tokens to the data layer? And that's where I think a lot of the like my current time is being spent. And so like the where we are ending at is like agents have harnesses, they have sandboxes, they can like explore, and like there's like good like orchestration layers behind it. But like, what is sort of like a roadmap or like a map that the agent can use in order to solve a data problem? And data problems are unique because they're not just markdown files. Like, the memory is not a markdown file alone. You also have Parquet, you have caches, you have expression graphs, and like so on. And I think the missing layer there is like what I'm calling a orientation layer. And this like orientation layer is think about a SQL database and how it has a catalog always, right? So if you're like familiar with like any like SQL workbenches, like like on the left there's a catalog tree, and I think like we want to abstract that like component out and make it multi-engine and Git native, so that it is also verifiable. We are already declarative anyway, so I think that's kind of where I think xorq is headed towards.
The difference
What do you
between
think of that? Yeah.
between orientation layer and the context, is it the same, or is it like specific for data workloads, or like what?
Yeah, so I think this is specific to a data workload. So this like orientation layer will have like things like expressions. So it's like an expression catalog. So you can do a list on it, and like that will show you entries that you can then like basically compose with. And that like composability is like, okay, this like catalog works in like two ways, that you can use it to discover what the other agents have already done, so you don't redo that work, and then you can use the entries to compose and build new entries. And like if you like think about a flywheel, that like like an agentic loop is like a flywheel. We are a flywheel in that way, where you go discover, compose, catalog, and you keep on doing that on each turn, or turn by turn. And that should and like that's kind of the vision there.
Yeah, in a sense, from all you saying and the way I'm building on top of agentic loops, it's what you're building is a CLI data platform in a sense, like something that is stateless, easily composable. This is something that you have like on your GitHub repo. It's like composable tools for data. And I think it's like a super good description of what it is. It's a way to give the catalog to the AI and also all the tools to let the AI build itself the data platform from the tools, and compound and compose and build the data platform. And so it's in some way a new way to build your data stack from tools that compose themselves, being stateless, etc., etc. And I think yeah, I think it's a great idea. The thing that is like the most hard, I guess, and this is the same also for now, it's how do you force or convince people to use xorq instead of letting Cloud Code writing this code, like ugly code or Cloud that compose, because no one cares anymore about like the code that is written. So how do you like convince people that xorq is better than like the so I have an illustration for this. In Now we released Now Stories. So Now Stories is a markdown with charts. But with Cloud Code, you can write React app that does a dashboard. How do I convince my users that it's better to use my markdown plus chart stuff rather than artifacts that generate React app? And it's the same for you. How do you convince users that it's better that the AI write xorq pipelines instead of ugly Python code that no one cares about anymore?
You don't need to convince the user. You need to convince his agent, right?
Maybe. I think it's both.
Hold on, we're not there yet, Julian. We need to,
but somehow,
no,
but in a sense, it's geo. It's like how are you discoverable by an agent, and that the agent most of the time prefer using xorq to do this transformation rather than writing the Python itself. And so at some point, you need to be like the default thing that humans would have chosen, because it's still like human that you have to convince first, because the tools that the AI are picking, it's by popularity, and the popularity is still determined by human at the moment. So it's still humans that you need to convince for the moment.
I think
friction is the thing, and we have to sell to an agent. That will happen too, I assume, at some point.
It's more a matter of friction. It should be frictionless for an agent to interact with your tool. Then, of course, you need to convince a human, which is still which drive the car, but still, I think the friction for agent is quite important.
I agree with that. So I think there's like I think we have an opportunity to rebuild the stack. And that opportunity, I think, like comes every so often. It's not that often that happens. The last time it happened was with like Hadoop in like 2008, and with a Spark in like about like 2010. And I think with like Claude Code, with the gravity that it has, it's bound to disrupt. So to me, it's actually a great thing because I can like convince people easier because I don't have to convince them to, hey, learn a new API, because that problem is solved. I can actually convince them on like how frictionless or how seamless it is to work with this agentic loop. So I think like a lot, like how do you make it so it's so easy for you to be installed in an agent harness? I think that pretty like an important metric. Like it should be, you know, super quick. And then I think, but your question I think is like a really good one. It's like, you know, why not just write some throwaway disposable code? And that's kind of what we're doing. And like pandas, you know, will work. And like even if it just works one time, I got my markdown file out and I'm going to be okay with that. I think I think at that level, what people might be missing out on, the repeatability, reproducibility for sure, and then that like code that you are throwing away is not quite just to throw away, because you probably want to build on top of it, or you know, like over time you were gonna want to build on top of it. So that is checked in somewhere. So I think that is important to kind of like understand where like the code is. And the other part about it is that how like xorq works is that we can actually make your code truly disposable, because the expression is kind of the artifact at the end that you can keep. So like the agent is compiling the code into this IR, or this like internal representation, and this internal representation is just stored, and it's very like transparent. You can look at the YAML files and like whatnot about it. And that I think is a big idea here.
This is funny because what you describe is a bit like the frontier between what data engineers is really doing in the company. It's like trying to build pipelines that are really reproducible, easy to maintain, etc. Whereas on the other side, like analysts and scientists will matter more on like the output, and they don't care most of the time of the way the pipeline has been built, and they maybe data scientists a bit different on the reproducibility, or data analysts sometimes different. But this is like what you describe is like the job of a data engineer, actually, like matter on how you reproduce the thing, how you orchestrate the task, or the pipeline and stuff like this. So yeah, and it boils down to, will data engineer still a job in the next months here?
I think that's a great question. What do you think about that? Do you think data engineering gets automated away?
It's hard to say, but what if you look at what was data engineering for the last 30 years, it was like moving data from A to B. Whatever is A, whatever is B, sometimes it's even A to A, but it's like moving data from one place to another. So it's piping, and it's like xorq in philosophically, I would say. And it's like moving data from A to B, and it's a lot of concepts, like a lot of concepts. Actually, data engineering, I think, is like super hard to master when you are a junior, because there are like so many concepts that you have to have in mind, like all the stuff around like determinism, idempotency, relaunching a pipeline, debugging a pipeline. And to be good at debugging, you have to be good at seeing things in the past that unlocks something in your memory that you okay, I've already seen this error like 2 years ago, so it might be easier for me to debug it. And this knowledge and theory has been simplified because of LLMs. And so LLMs will be maybe good at helping you fixing stuff autonomously. So I think one part of the data engineering job might be like fixed, but on the part of designing good pipelines, having like simple pipelines that are easy to operate, I'm not sure we are there yet, and I'm not sure we'll be able to be there yet without a human in the loop.
I think it's just a matter of complexity. So like
Yes.
Today we have complexity level 1, and if we can do like all the level 1 easily, then we're just gonna go to level 2, and like the whole complexity is gonna shift up and they're just gonna do more pipelines, more complex things, and because the demand as well is gonna increase. So just a matter of, like, the demand is gonna increase, we're gonna create more pipelines that are more complex, and at the end we'll still want to be at the edge, like, of the complexity somehow. And I think that's why we will always need, like, this kind of data engineer. Data engineers.
Yeah, and maybe it's data engineer or software engineers, but people that are like focusing on moving data and transforming data.
What do you guys think is like a do you think a gas town like thing for data engineering may exist where there's a or does it already exist?
We talked about this last week with Christophe. Like, it was in French, but we need some kind of new orchestrator. Like, I think the next today we are pushing code to production, and then the code is moving data. And I think tomorrow we will push a swarm of agents with prompts, with guardrails, with QA process and everything, and they will build a pipeline. So that will completely shift. But in order to do that, we need a new kind of orchestrator somehow, which go, like, we don't need like the full Airflow probably. We need the Airflow core plus some add-ons to manage agents, and that's, I think, what is described here. We don't need to have like fixed trees, but like more flexibility. I think Christophe,
the thing that clicked for me is, like, maybe you know it. It's like these 12-factor agents. It's like they're trying to reproduce what is the 12-factor for software, but for agents, and they have like this way to phrase it that is interesting, and it's a good thought, which is 60 years ago, software was just a directed graph with some if-else and deciding in which branch we were going. Then we went from like code to DAGs, and so 20 years ago we decided to go for DAG orchestrators. So you have like a deterministic path, and you have either an event or a cron that triggers a deterministic path, and then you have like end that is fixed, and so you are expecting an end at your DAG at the end. And with the agents, like, the promise is a bit different. You have some kind of event or a cron still, whatever, that triggers something. And then you have like a LLM orchestrator that is deciding among all the tasks that you are available to you or to the agents, what is the path that it should take. And then you achieve a goal. And so it creates some kind of orchestration that is a bit different. It's less deterministic in a sense. Most of the time, you decide, you say to the agent, oh, you have to do this. You have these tools, and the tools are kind of task in a DAG. But the agent decide every time he wants to run what is like the path between the tools. And so for this, if we want to push this in the data world, there is some kind of new way to orchestrate the task that we have to think about. And maybe also the philosophy is like, should we stick for deterministic DAGs here, but the DAGs are written deterministically by Cloud Code or whatever AI agent that you want. And so you create like some kind of package where the code has been written by an agent that is non-deterministic, but the DAG is still deterministic at the end? Or should we go for live system where you just like consume token to decide each time what is the path that you want to take for each task? So for instance, like the question that we said last week is like, when I want to move data from Postgres to BigQuery, every day, should I take a different path or should I stick to something that is deterministic?
Yeah, I mean, I think that's a really good point, and I think this is a very good articulation of it. But I think the deterministic part is pretty important, because how do you verify things are working correctly? And like, verification for me is like, things like, hey, did you use any PII data in this pipeline? Is there a pivot on that PII column? I think those are like, I think the deterministic is definitely the right thing. Is like, you wanna, but you want the agent to basically compose these like building blocks. So I think you can have a world where if things are composable and everything is like a Lego block, the agents essentially compose only, and you don't have to really provide them anything more than that, I think. What do you think of that?
I do agree on this, and actually we are like in the hybrid part at the moment. In the development phase, you ask an agent to do something, and you ask the agent to do some kind of decomposition, and then at the end you take it and you push it in production. So it's like where we are at the moment. But what we were also saying is the annoying part of the data engineering is when in the pipeline something breaks and block all the downstream operation. And the agents are super good to self-heal themselves or eventually even fix themselves downstream. So maybe we need an orchestrator that is self-healing in a sense where, I don't know, if I've ingested something from Postgres and the colon has been changed, the type has been changed, the volume has been changed, whatever, something upstream made my pipeline fail. I need my orchestrator because it can connect to some kind of reasoning, tokens, whatever, self-heal itself without even waiting for some monitoring tool observation loop that comes on top and try to fix it in a way, passing the Git, the peer reviews, and so on. And so you have like a system that auto-evolves from a deterministic standpoint at the beginning.
We have intelligence available, like almost for free. There is no reason we not onboard it inside our pipelines, but we need to do it in the smart way, right?
That's right.
Maybe we should. Yeah, go ahead.
Oh no, I was going to ask a question. What would you say are some of the properties that are necessary for this layer, this like orchestration layer? You said determinism. You said composable. And composable and deterministic is like a really good combo because now you can do things like verification. What else do you think is there?
I would say composable and checkpointing,
caching,
checkpointing, and stuff like this. Because if the agent or the orchestrator goes in a task and you cannot like it lasts for 1 hour, but you could have sliced it in smaller tasks and start again from a better checkpoint would be good. And then
I think we need gates, quality gates.
Yeah,
quality gates
and like proof-based gates. Like the agent must provide proof that this job is done, and this proof needs to be reviewed by another agent, like pure QA workflows.
Or agent or deterministic checks. I think it's way better if you can have like deterministic checks.
Even better, right?
And I think that there is one thing that, because we still live in a human world, which is like budget constraint. Because for instance, if you don't put like some kind of time conversion, convergence, like if you don't ask the LLM or the orchestrator that self-heals to converge, at some point you're gonna have issues because, for instance, it could loop for 1 hour, 2 hours. So you need some stuff that makes it timeout. So the timeout might be on time, might be on budget, might be on number of token, might be on number of loop it tried to fix stuff, and adapt the orchestrator on this, because this is important that you don't have like a loop that runs for the whole night, burning token for nothing.
That's more like observability now as well, like the classical observability things that we have today. We should just adapt it to the new.
To me, it's not observability. It's more something that should be embedded in the orchestrator, because in the orchestrator at the moment in Airflow, you have, for instance, retry. You say retry 3 times in 15 minutes. And so if you create a new kind of retry, you have to have this kind of stuff in the retry, like do not burn more than X tokens or stuff like this.
That makes a lot of sense. And so when we're talking about retries, that basically means that we have some state. So you want this orchestrator to manage and self-heal based on the state. So so how would this be different than the or how would it interact with the agent loop or the agentic loop?
I think one task, I mean, you have task, and each task should be a loop by itself, and then the agent navigates then the DAG of task like that. And yeah, I don't know if it's
but there are like so many design choices to do in the agentic loop, because the agentic loop can be like monodimensional, like only one agent loop, or could have sub agents. And if you have sub agents, I think it's like depend on the choices that you want to do on the agentic loop and how you want to do it.
Right. So this this orchestration layer would be pretty deeply tied to the agentic loop. If not, maybe even like a superset, would you say?
Yeah. I think it depends. The best and the funny one would be like, deeply tied with the agentic loop. I think the first version should be something that is not that deeply tied with the agentic loop. It's more something that is, okay, the agentic loop has written some kind of DAG. In this DAG, there is like at some moment, we're gonna ask the agentic loop to do some stuff, but there is still this deterministic path that it takes, because once again, if you want to copy Postgres to BigQuery, you don't want to call OpenAI to decide how you extract data from Postgres every time, every day, every hour. I don't know.
Exactly. Right. So like, would like dbt come close to that? I guess.
What do you mean, like dbt Labs, the company, or dbt Core, the tool?
the tool.
No, nowhere that.
Nowhere.
To me, DBT core is like something that is on top of an engine that is only doing SQL. So it's like the worst
You want something
orchestrator.
generic.
It's the worst orchestrator that exists out there, like DBT core, if I can say it this way. But it's like a one that is working. It's a one that is working, but it's the worst that is out there.
We need the same ideas, like to bind transformation with each other. The idea is correct, but the implementation is wrong now, probably, or it's not adapted to the new world, probably. Like the idea of having chain transformation with each other, I think that's still correct. And like you can execute part of the DAG, can execute the full DAG downstream. I think the problems is still here, but we need new way to solve it, probably.
And there is also a matter of materialization, because do you want to materialize stuff? And what should be the best way to materialize stuff? Like, do you materialize each time the DAG runs, or do you materialize using the real-time views on Snowflake, for instance? I don't remember the name. The views that it's like a view, but it materializes every time like a new event arrive on it. And so if you do this, you don't really need a super advanced transformation layer like xorq, because you just push like the SQL code to Snowflake, and Snowflake can do all the orchestration stuff. So, but in the end, you don't want to put all your eggs in Snowflake, so you want to get out of this. So you need something that still orchestrates the Snowflake layer and have multi-engine. So this is something that you have like so many solutions that exist out there.
I think this, like what you are describing, is like fascinating to me, because I think this is what we need to figure out as a community, right? And hopefully in the open source, like I've been using, or like in my sort of like a taxonomy of this like architecture, like I think what you are describing is more like a harness to me. It's like an agent harness where there's like Cloud Code in this. There's all the a sandbox in it as well. So you have like a Git native tooling. You have your tool use or function calling, and I think those are all the things that you can that basically build this system. And then you want to be able to connect to, like, say my Snowflake or my Postgres.
Yeah, I agree. All this vocabulary, and like there is like the harness and all the stuff that you expose to the harness, and what is in the world of agentic analytics, because we are in the data world. So what we want to bring to users is some kind of agentic data or agentic analytics. What is the external part of the harness? What is that the tools? It's mainly the tools and the context that we need to bring to the harness, so the harness works correctly.
Indeed. And like what is the shape of those tools, right? I think that's what I am like super curious on. And I think in this conversation we kind of like double clicked on it. Like, it needs to be deterministic, it needs to be composable, it needs to be discoverable, and I think those are or verifiable. I think those are the types of things that like those are the properties of the tool that you need to have in order to work in this harness. And like maybe this harness is the best thing that happens because it breaks all the walled gardens and all of these like just siloed proprietary systems, because everybody has to participate in this. And the way to participate in this is like building those like Unix pipe, like, composable tools that can work in this harness. And these are all essentially bash tools, right? What do you think of that?
I think, yeah, I mean, there is a lot of discussion today about MCP via CLI, and it's like kind of emotional somehow. I don't know. It's like something really important right now, and everybody is chatting about it. They probably both have their use cases. For my personal view, is like as soon as you need to connect to something outside, MCP is probably good. And once you're doing things internally, like on the same machine, like something which are close to each other, then CLI is probably a good option. But that's maybe wrong, and that's just based on my own experience, I would say. I know that now I think you are exposing MCP. You're allowing MCP to be used, and probably CLI as well, I guess, in your Python sandbox. I don't know what your vision is, because you're basically offering both.
Yeah, I think so. My opinion since the beginning is like, I feel MCP, the way they are implemented today, are super bad, but mainly because we implemented the MCP super badly. Like the one of the key demonstrator of this is the GitHub MCP. if you add the GitHub MCP with all the tools, I think it's like 40K tokens or something like this, 20K tokens in your agentic loop, which is like crazy in terms of amount of tokens that it adds. If you, in comparison, but the comparison is not fair, if you add like the GHCLI to your agentic loop as a bash tool, it's nothing, because like the model has been trained on it, or the model can operate it, because there is like this discoverability in the CLI that is GH help, GH PR help, and then it discovers the thing progressively, I would say. But in the end, maybe in the consummation of token, it's not that better, because you have to discover the thing that you want to use. So you use like loops in your agentic loop to decide, whereas in the tools, it's already like in the context, and you let the orchestrator LLM decide. So I think both things have their advantages.
But this has changed a lot, because MCP was created before we have this local running coding agent with the bash and everything. And that's why we had MCP, which would allow them to be pluggable directly inside the LLM, and without having a file system with CLI and everything. I think this new coding agent running with on top of a bash has changed a lot of things, like the tool that we're using. And that's why CLI are suddenly coming back, right? Because it's just much more simple.
I disagree a bit. The reason the CLI is like interesting, it's because mainly it's stateless. That to me, it's like the only key point in this, because actually what the CLI of GitHub is doing, it's literally the same calls that the MCP is doing on the underlying layer. It calls the same endpoints of the API. So it's like literally the same thing. The only difference is that it's more handy to use a CLI because it's stateless, because it doesn't start a server that has to be running somewhere that is doing some kind of proxy on another API. And I feel this is like the main thing that make it more that make it handier. But at the end, like this is the same kind of interfaces. That this is just like a different way to operate it, but this is totally the same thing to me.
If you have bad API, you have bad MCP. If you have good API, you have good MCP.
And it's the same for the CLI. Actually, like
if you have good API, you have the right endpoint that can serve your agent, and then you have just a matter of distribution, right? Probably MCP or CLI. It's just the last mile.
Yes.
That I think to me that's the key. Is it's about like distribution. Like if I'm an enterprise and I want to build an authentication system that is like MCP is behind an auth, and there's an easy way for you to like I want to run everything somewhere else remotely. I think that's where MCP comes in. And then I also find that your Claude desktop, like MCP is the way to go for it, right? Like I guess things have changed with xorq. xorq was also one of those, I think, moments in our timeline that kind of like opened up the eyes.
The thing is, so AI companies and frontier labs tried like for 1 year to decide what is like the best use case to use AI. They tried like many verticals, and it happens that Anthropic found it first. It's like coders that are like the most easier, the easier to convince and the easier to adopt new technologies. And when actually you think about it, like code is just a representation of the business into files that are programmatic files. But actually, if you take a company, a lot of the job that other verticals in the company are doing can be also transposed to files. And this is why like this is the hype of Markdown at the moment, because if you put like the company knowledge or the company work that you are doing as a marketing person, as an ops person, as a whatever person into Markdowns, it means that you can run Cloud Code on top. And xorq is just like a easier UI UX on top of this, but this is literally like the transposition of like running Cloud Code on top of Markdown that runs your company, but with a nicer UI, I would say.
Yeah. How do you feel about that? How do you feel about Markdown running your company? I think that is scary to me.
When you look like Notion, it's a cool product. It's a funny UI, but I'm good with like moving all the stuff that I have in Notion that I don't even read into Markdown's file. Maybe it's the co-founder that will have an issue, but it's not me as a dev, you know.
Yeah.
Why are you afraid of Markdown for running your company? What's your
like I think it's not Markdown per se. It's just like text,
text.
and like free form LLM generated memory files that like I wish there was more like care put into that, right? Like, but I'm not saying like it doesn't work. I think it like works and it's nice. But for like as we like scale, I think that will develop into maybe there's like plugins where you can bring in your own memory systems. And there could be a whole way of like building out a architecture and like, you know, sort of expanding the harness is through these like memory plugins. I wonder about that. It's very like vague in my head, and but I think it's like interesting.
Composability is probably the keyword here. You need to compose somehow your memory across coming from different departments, right, in your company.
But it depends
Exactly.
what you call memory. I would say it's more like a matter of information retrieval. Like when you have like a few thousand documents, maybe it's like feasible, or I can think about it. When you have hundreds of thousand documents, this is like another level, and this is why we pay Google Drive to handle these documents, because hundred of thousand documents do not lie in a GitHub repo. It doesn't work that much. It's not super easily like searchable. And at that level, you will need to have some RAG or RAG that works. And maybe at some point, we're going to pay Google Drive to do it. And we're going to have like proper APIs to do RAGs on top of Google Drive documents, because that's what we should pay for when we pay for Workspace, not to like host a few slides and documents. We should pay for a way to browse the document that we have in the system that we pay the storage for, I would say. Why me as a data engineer should I annoy myself to take all the documents that I have in my drive, do embeddings, put it in BigQuery, then put a harness on top of it, just for my company to be able to search the knowledge that I have in my company?
I think it's already exists. I think Google provides that, like embeddings on top of your documents. But I think it's really hard to navigate and not really clean and everything. But that will that will come. That's for sure. It's like obvious opportunity for Google Drive team. Thank you, Hussain. Thank you, Christophe. It was a super nice chat. And I don't know if you want to add some closing words, both of you, about like what's coming next and what you're really enjoying right now, or like what you're feeling at the moment, and like something like nice to close the show.
Absolutely. Yeah. Thank you for having me. So for me, my next steps, I am excited about doing our like the proper launch with the cloud product for xorq, and we are just slating that in the next few weeks. And that's been keeping me both busy and excited. So from a call to action standpoint, check us out on GitHub and give us a star. We're called xorq, xorq.
Yeah, I've put it like in the screen share just before, and I will put it in the link in the video. So thank you so much. Don't forget to like and subscribe to the channel and on Spotify and Apple Podcasts as well.
We need this like this ring on the side, like don't forget to like.
Yeah, that's true.
Here are my 2 videos.
And see you next week.
Thank you. See you. Bye bye.
Take care. Bye.